Hey, I wanted to make a quick video because a lot of you guys had trouble with Activity 3 with the Franklin's bells and the lightning rods and the Van de Graaff and the cans. So I wanted to talk you through how this whole thing works step by step. So we have our setup here, the Van de Graaff generator, which produces a positive charge. The electrons are being drawn out of it, so it's producing a positive charge. And that's transferring through this wire into can 1 here. Then we have this ball that's starting off neutral, and a can 2 that is also starting off neutral. So the first thing that you need to understand to make sense of all of this is this figure. What we have here are two positive charges and a positive charged like mobile object that can swing back and forth. So what you're supposed to figure out from this one is that one of these has a stronger charge. If this positive ball is going towards part B, then that means that this one has a stronger charge, because what is the force that's going on here is repulsion. They all are repelling each other, but this one has a stronger charge, so it's repelling the most. Okay, so here's our setup again. So how is that going to influence this ball? This ball is essentially that middle positive charged object between the other two. It's not positively charged yet. Right now it's just neutral. But when we turn this Van de Graaff generator on and it's starting to make that positive charge, and that positive charge is coming through this wire and getting into can 1, then all of a sudden this neutral ball is going to be attracted to that charge, right? Because that charge wants to balance itself out, so it's going to pull in that neutral one to balance the charges. Okay, so that's what we see here. Positive can, neutral ball, and then as soon as this can becomes charged, that neutral ball is going to go towards it. Sorry, it's crazy in my house, like always, but definitely right now. So, okay, so then that ball, which was neutral, comes here, and it is going to tap can 1, and it's going to pick up that charge from can 1. So now the ball is positively charged, and the can is positively charged. So that ball is now going to repel, right? This is where we have, this is the stronger charge, and it's repelling that ball. So the ball is going here towards can 2, which right now is neutral, right? So this ball is now seeking to get rid of its extra positive charge by going over to can 2. Okay, so let's watch this video real quick and we'll see if we can see all that happening. So lots of charges being diffused here. And this can, because it's not connected to the Van de Graaff, has a weaker charge. It can diffuse that charge. But as soon as, actually I said that wrong. What's happening is that as that ball, as the system becomes still again, hold on, so let's take it back to like right here. As that system becomes still again, it's because that positive charge has evened itself out throughout the whole system, right? So everything has a consistent charge when that ball is holding still. It doesn't mean that there's no charge. It means that the repulsion is like even between everything. But then, so then as soon as she puts her hand near, okay, so that's where the charges are even. But as soon as she puts her hand near it again, then those charges can leave can 2, right? So now that's all even with no charge, right? Let's watch it one more time and look at what happens here. I'll just skip forward a little bit. Okay, so we see what it looks like. Okay, so she's turning the Van de Graaff on. Charges coming from the Van de Graaff to the cans. Charges are being transferred back and forth and back and forth and back and forth. And they continue to transfer back and forth because this can is letting the charge go. But then the charges kind of even out. But, yeah. So when the charges are even, the ball is holding still, whether they're evenly charged or evenly neutral. But when she brings her hand near it, then that that charge is being drawn out again, so then that charge is unequal again. Okay, let's come back to the slideshow. Okay, so then how does this relate to thunderclouds and lightning, right? Okay, so when a thundercloud is forming, there's a lot of friction going on. The particles are rubbing together and it's causing the static buildup of charge. So meaning the charges are becoming separated. We've got these positive charges up at the top of the cloud, negative charges at the bottom of the cloud, and those negative charges are making the negative charges in the earth, which was formerly neutral. Those negative charges in the earth are pushed downward. So they're still there, but they're being repelled by that giant negative bottom of the cloud. Okay, so that means that the ground here is positively charged because those negative charges are pushed downward. So we have a lightning rod here, and lightning rods are cool because they are made of metal, which doesn't give them a charge automatically, but it means that they conduct charges well. So some of you guys said that the positive charge was coming up through the lightning rod, causing that lightning to attract to it. But more accurately, what's going on there is that the lightning rod is fairly neutral to start with, and then as this charged cloud comes over, that lightning rod can conduct the negative charges from the cloud into the bells. So the bells don't need a lightning strike to form. The bells just need a charged cloud to come over, and it's going to make them ring like that. So the other important part to know about the bells and the cans is that you have this bell that's connected to the lightning rod, the ball that starts off as neutral, right? Then you have this grounded bell, and that grounded one is something that is grounded takes the extra charge out of the system and puts it back into the ground where it can be neutralized. So that's how there's this uneven charge, because as soon as this bell picks up a charge, it's going to let it go. So that's what keeps this bell ringing back and forth as long as there's an imbalance of charges. More charges up in the air than there are down in the ground. Now, a ground is not going to transfer charges back up to the bells because it's consistently diffusing those charges. So if there is a charge on these bells at all, it's because it's picking it up from the air around it. So it's possible that the bells are charged slightly positively because the ground around them is slightly positively charged. But any negative charge that's coming from the clouds is going to be transferred out into the ground there. Okay, so I hope that this helps. I hope that it makes a little bit more sense of it for you. And feel free to contact me if you have more questions. Feel free to redo Activity 3's Google form if you want to get a better score on it. And I hope that this helps for the test too. So we'll see you soon. Thanks.